Most objects reflect at least some portion of the light falling on them. Just look around the room you're sitting in right now. You can see the objects around you because some of the light in the room reflects off the objects and travels to your eyes. The reflection of light off the surface of objects can be broadly classified as one of two types, either specular reflection or diffuse reflection. In specular reflection, the surface of the object is smooth and shiny, like that of a mirror. The figure shows that upon specular reflection, incident light rays that are parallel are still parallel after reflection. However, many objects have surfaces that are not shiny and smooth. A piece of paper, for example, may look smooth, but if you look microscopically at the surface of the paper, you see that it is irregular and fibrous. Because of the roughness of the surface, the incident light rays that are parallel reflect in all directions. However, in both cases, the light rays are obeying what's known as the law of reflection. We demonstrate this law by looking at the reflection of light off the surface of a mirror as the figure shows. The dashed line is perpendicular to the surface of the mirror and is called the normal to the surface. The incident light ray strikes the mirror at an incident angle, theta incident, which is measured relative to the normal, and the reflected light ray leaves the mirror at a reflected angle, theta reflected, which is also measured relative to the normal. The law of reflection describes the behavior of the incident and reflected light rays. If the incident ray, the reflected ray, and the normal to the surface all lie in the same plane, then the angle of reflection equals the angle of incidence. The following clip shows laser light reflecting off of a mirrored surface. The light rays in the reflected laser beam are all parallel, so the dot of laser light is preserved after specular reflection. And it is clear that the angle of incidence is equal to the angle of reflection. If the incident angle is increased, then the reflected angle also increases by the same amount. In contrast to this is what occurs if the laser light undergoes diffuse reflection. We can demonstrate this by shining the laser light onto a piece of paper. Upon reflection, the light rays in the laser beam are no longer parallel, but reflect in random directions, thereby diffusing or spreading out the dot of laser light.